Okay. Okay, I'll start. Okay, so I'll explain a bit about the InstructionFusion Pass. It's about this pass is responsible for vertical fusion, like so if you have like this producer, we just call it producer of like A and producer of B, and then consumer of AB. We want to like fuse them into one fuse computation if we think it's beneficial. So the core purpose is like if we fuse them, we will not read or write to memory as often. So that's the key thing. So if it was, for example, GPU case, it will be merged into a single GPU kernel. So there will be not much memory read and write. And the CPU case, I guess it will be more in the cache locality. Like it will be more cached. So in between each instructions, there will be less likely to be a memory read or write. So high level flow, there will be pre-analysis phase. And then it will go through global graph and then see if each instructions can be possibly fused or not. So it will have do not fuse kind of mapping. So it will mark some instructions as do not fuse them because it's definitely not a good idea. So, and then it will have fusion queue.
Can I have a question?
Yeah.
In which case you can say it's not beneficial to merge?
Yeah, I'll get into it back. But it's just not a high level flow. I'll get into each phase again. And then we'll have a fusion queue. So it will go like from bottom up. So it will try to fuse one by one by going in like, so each instruction, each producer consumer pair will have like, I think should fuse flags, like, so, which will mark that it's good idea to fuse them. Okay. And so the global analysis is, so if the total size of the input operands is less than the output, it's going to be beneficial because let's say if it was a broadcast, then broadcast is like, it has like, let's say one element and then broadcast into array, right? So the output size is much larger than broadcast. So if we fuse them inside the computation, let's say here we have broadcast, then the input to this fusion will be one element. And instead of the output of broadcast, which will be array, right? So in that case, the operand is going to be one element instead of an array. So it's going to be like much beneficial to fuse. And then if not, we will check if we can actually fuse them to all its consumers. So if the producer A has multiple consumer, then we'll check if this can be fused to all of them. If not, we will not fuse it. If yes, we will fuse it to all of them, right? So the key idea here is, so let's say we had like producer like A, and then like consumer B, C. Then if we fuse only these two, then still outside we will have like producer A, this sequence outside because we couldn't fuse them together. So in the first two will be like fused, right? So the output after the fusion will be this. So the idea is, so this A is gonna be computed anyways, and there is this memory read anyways. So it's less likely to be a beneficial case for us. So we will not do this. So yeah, if it's not if it's not either of these two, we will add it to do not duplicate. So it actually we will add it to do not duplicate, which means so if it has only one consumer, actually yeah, you will add it to do not.
There's no edge case like there are multiple consumers and the case that benefit with views per each consumer.
No, I think there's no use case. So this is about global infeasible. So here, there is this guy which maybe I forgot to mention. Did I mention? Okay, so at most unary, this guy, what it does is, so let's say this is only one of the operand is large size, and the others are, so this part, right? And the others are
Relatively small.
yeah, relatively small. So it could have a lot of operands. So that's why like but still they are small, so we don't really actually like consider their shape. Okay, so if it has like only one operand that has a large shape, then we will consider this is at most like this is always beneficial to fuse because it will I think it said like oh there's no explanation here. So I think it said like it's not gonna change the fuse computation's input much. So fuse computation is so let's get it back to here. So we had A and B. So the B had A as an input, right? So instead of this, we want to fuse them. So the fuse computation will have the input A, right? If we fuse them, we will have this. So let's see. Very. So before fusion, we will have A and then consumer of A. And then after fusion, inside there will be both. Actually, let's see. This is like this. Well, small A, okay. So this A is approximately same size as this one, right? That at most unary is asking. So instead of BA, we are changing to this one, right? After fusion, fused AB. Okay, let's see. This is fused AB.
Okay, question. So, in this case, A operation or A instruction only has a single operand.
Yeah.
So I don't think that the at most unary will be true, but I think at most unary we have to have a operand more than two, right?
Small one, like small.
Oh,
two,
yeah.
We can have this, but we will ignore this. So yeah, in here we will have small one, small two, but what we care is the total memory reader, right? So either we can have BA computation or we can have this one, right?
I see. So if you take the size of small one and small two into consideration, then check memory transfer will return first because total size of output is much greater. But if you take A into consideration, then the condition for this is true, so that it can be merged. And is it true? If it's true, then my last question is like, which instruction have this situation?
Oh, actually, I'm not sure about that. I think. I'm not sure about that. And actually, also, I was confused in like what element. What was it? Affect unary at most. So I was wondering like why is it like comparing like greater or equal? I mean, I thought it should be like smaller. Like, but then obviously it's gonna.
Is it because two have a beneficial for fusion input length should be greater than output. Because it
It should be on.
comparing rank. See what you meant?
Yeah, but I mean, no, I was actually confused about this one. So I thought like input shape,
Mhm.
the operand shape should be smaller than the output to be beneficial.
Shape means size of dimension.
Yeah,
Let's say 3 by 2.
but I
See-
guess it's flattened, so I guess I don't know actually.
Is he talking about like reducing kind of, if your rank is reduced, which means it's reduced operation kind of.
Mhm.
Reduce take like many operation, and if the one of the operand of the reduce is very big,
Mhm.
then
It's beneficial to
yeah,
stay
because
fused.
reduce like operation try to get much smaller output size compared to the input size.
Yeah, so I mean, in that case, why is it beneficial to fuse them? Because it means we will have to load more from memory, right? So if we just take in the output is smaller, so it's gonna be.
For the first check part of the fusion,
Mhm.
if you
It's
go
actually
back,
Mhm.
go back, if the size of the, so for example, you take as an example of like broadcast is rejected because the output size is much bigger than input size. In that case, we're not going to fusion.
we will fuse broadcast.
Oh, you said that?
Yeah, fuse will be. I mean, broadcast will fuse because the input size is much smaller. So if we fuse them, it means our fuse computation input is gonna be smaller in memory size, right?
I see.
So-
I thought it was differently. So broadcast is allowed, reduce is not allowed.
I think I'm not sure if reduce is allowed or not, but it seems it can be allowed because if it's actually, so this is like must. So this is like do not duplicate. So I mean, do not kind of. So more than unary is fusing the likelihood to increase in them. So yeah, I think reduce will get into this one because it has only one operand that is approximately same rank as the output. So I think it can be still fused, but I'm not sure why it will be fused because I mean because the input size is much larger than the output size of the reduce rate. But maybe it will still not be fused.
But is it safe to say that the input size is bigger than the output size because it's only comparing rank, not a size?
But if rank is bigger, it's likely to be bigger.
Likely, but not always.
Yeah, I mean, I know that this check or logics are a bit flawed. Maybe there is some bad edge cases,
Mm.
but the current state of the pass is like this. So I guess it could be more improved on. So anyways, the globally unfeasible is only does not mark this unary cases. It only marks like the large memory case, which are not like fusible to all paths. Okay, so yeah, that's the overall idea. And then we will go for the fusion queue. It will go if it's null, it will pop until it's not null, and then yeah, and yeah. So this is just a post order queue. So there is in the should fuse logic, we have main logic is here. So if fusion would duplicate and
You
we,
mean the producer duplicated?
yeah, fusion would duplicate the producer.
Mm.
Consumer is always the target. So yeah. So if duplication is required, and yeah, this flag can be turned on or off. So if it's like off, then we will only fuse basically this one. I mean, we will only duplicate always duplicable. So the always duplicable cases are like broadcast or scatter also, I think. So. Yeah. So I can. It's always. This guy has only. Oh, what? So convert broadcast and file size of the current is smaller than the file size.
Convert, like for example, convert int 32 to convert to F64.
Int 32 to F64. I see. Okay. Yeah. Oh. So fast. Yeah, that's so if it's like converting to bigger type, then we will always duplicate it. So even if the flag is off, I mean, if the duplication is disabled, we will always duplicate these parts. And so these are the logic. Is expensive. So there is also this it's expensive call. So
It's kind of overwritten, kind of.
yeah, it can be overwritten.
Maybe I added a comment around this, right?
Maybe, yeah. So here, so these are all cheap considered. Okay, so absolute, etc. Add mostly element-wise operations, and then what else? So divide and remainder. So I guess it is.
Cheap when it is integral floating point will be expensive.
Yeah, I think so.
Then what about build?
So I actually put it one of the things here inverse. I put it here.
Thank you.
Expensive. So
then divide. Our
Divide-
case integer is not a okay.
yeah.
I see. What about group add? Read curve addition.
Yeah, we need to be, I
Extension
guess,
field
add
addition.
some condition here, right? So, yeah, we need, I think we can improve on this. So, yeah, that one is there.
Then another question is for me, like, so let's say you're going to, so in my expectation, like, let's say we have a element-wise field addition loops, and I want them to be, for example, group addition, I want them to be merged together. But if I look at this, this condition, if it is, for example, it was integer loop that is merged, if it is like a field addition is not merged, or group addition is not merged, in which case?
So now all addition is not expensive, right? So it will always be merged, right? It will always be fused because it's cheap. But if you don't want to merge like group addition, then we need to add condition here, like if it's field.
Yeah. Then let's talk about divide and remainder. So for example, if we have a floating division operation,
Floating? You mean integer?
Yeah, let's assume that we have a floating point types.
Okay.
And if we have a two element-wise division, and it looks like it doesn't try to merge these two loops into single loop.
Why?
Because it treated as an expensive operation, and it rejects to be used.
You mean because it's checks if it's
Yeah.
I mean, I removed the floating check, I think, probably.
Then another question. Then why is true for integer division and why is not true for field division?
Field division is inverse, right?
Yeah, divide is like multiplication with the inverse of something, right?
Yeah. So I didn't give much thought to it, but I thought, yeah, if it's field, then it's gonna be inverse. So I mean, I have inverse at expensive. So
so my question is like, why there's no benefit if your operation is expensive?
So basically, it will duplicate, right? So if we fuse, let's say A into B and C, Then
if there's a duplication case, then we think that.
yes, yes, yes. So
It's
it's that branch. Where is it? So this branch,
ah,
fusion with duplicate, it start with, right?
ah,
And
ah,
expensive.
I see, I see, I see. If there's no duplication, then always merge.
Yeah, I think so.
I see, I see.
So that's the idea. And actually, this guy has shoot, so at the end, it calls this should fuse in place check. So the in place case is a bit complicated because it thinks it will yeah, this is like 200 lines of logic. So it was kind of tough to read, and basically it is trying to make sure it's fine to fuse, because as also in the Rice presentation, the in place can make it corrupt, right? So without, let's say the producer is about the first loop is, let's say, iterating reads like 10 to 20, and the consumer updates like 0 to 15, let's say. Then without fusion, this will run fine. After, and this will run fine because basically between them we have synchronized, right? We have synchronized. So first loop runs and then second loop runs. But in the new after fusion, it's gonna be this loop is basically gonna be fused together. So it's gonna be like corrupted. So if it's element wise, obviously it's gonna be much fine. But if it's other case, there is, I think, some complicated.
If you merge together and if the producer runs before the consumer, then isn't it fine? Even if it is merged?
That's actually also my idea. But if you think of in terms of loop, then it's not fine, right? Because so in here we have the synchronized, so all iterations will be done of A, and then after fusion, it's gonna be one iteration of A and then one iteration of B and then one iteration of A. So that's why if the one iteration of B can affect the second iteration of A,
Yes, yes, yes.
then fusion can make it corrupt, right?
Oh,
I think that's the logic.
okay.
I didn't go line by line, but yeah, I think that's the logic.
But yeah, I know, but my imagination is like if the read operation is always executed first before write operation at every index, then I thought it's fine, but there will be like edge case.
Could be. So I think the problem is, so let's say this guy writes like all elements, okay? The consumer writes all elements. Then it will affect the second iteration of producer, right?
I see, I see.
Yeah, so that's all, I think. So yeah, this is just a fusion loop, the fusion logic. And after each fusion, it will update the operands, and then yeah.
Yes.
Yeah. So if you have any questions, I will maybe add more info on this. But yeah, just I prepared.
Can I have a question? So according to the pre-analysis, reduction is always rejected, right? Procat is allowed, reduction is rejected.
I think so. I think one easy way to check is if it's expensive, not this expensive. But I'm actually not 100% sure. Reduce. I think actually it's yeah, it's considered expensive. Yeah, scatter is also expensive actually.
Then my question is like, because I remember have seen reduction fusion, and how is it generated?
I think that is maybe separate. So on top of this, probably there is another fusion passes. So after running this, if you run reduction fusion, some reductions will be fused. So
I see.
yeah, this is, I guess, the
Ah.
base instruction fusion, which will fuse these simple cases, I guess.
Group and pro cascade, I see.
And so yeah, cheap instructions are absolutely bad. And I also was bringing in some transpose folding pass.
Folding?
Transpose
Constant-
folding.
constant folding?
Transpose.
Folding? What do you mean by folding?
Actually, it's same as the Zigzag folding, or you can say fusion also. It kind of fused together dot with transpose, and
I see. It's also inside in the same PR or
no, I think it's gonna be the next.
Oh, I see. Okay.
Okay, I'll stop recording.
Thank you. I will review in the evening.
How was-
Fine.
Yep. How was the presentation? My first presentation. Very high level.